Hi, in this video, we're going to talk about the application of integration in finding the area and volume of a curve that enclosed in a region where enclosed by a curve or a straight line or axis. All right, so we're going to find that area by using the concept of integration. All right, so okay, look at this the question saying that find the area enclosed or bounded by the x-axis and the following curve. So of course we must know what is the curve, right? The shape of the curve. So we have to know where's the curve locate. So as x squared negative 4, the curve will be moving this way, right? It's a quadratic curve, all right, concave upwards. So where they will intercept at 2 and negative 2, right? As you're very familiar with this graph, so it's a x squared minus 4 graph. So it's from negative 1, all right, from negative 1 up to 4, right? Up to 4. So means that there is a region below the x-axis, right? Below the x-axis, and there is a region above the x-axis here. So as you have learned this before, while you're integrating the graph, integrating from negative 1 to 2 for this function, you are getting a negative value. So and the area of the area cannot accept a negative value, as we know that we are actually evaluating the area. So area should be positive, right? We talk about the area. So if you take this as a negative and this is positive, you sum up the total area, it will be lesser, right? So means that for this region, I'm going to divide this into two regions. For area of A, I'm going to for this region, if you integrate, so area of A, area of region A, so you are getting integrate from negative 1 up to 2, okay? From negative 1 up to 2. So whereas I integrate with respect to x squared minus 4, as this is between the curve and the x-axis, right? So, all right. So as you're evaluating, you are getting x cubed over 3 negative 4x, right? X cubed over 3 or minus with 4x. So it's from negative 1 up to 2, so where you need to evaluate. You have to evaluate this curve here. So you are getting, then you're putting 8 over 3, 4, right? 4 times 2 minus with negative 1 to the power of 3 over 3 minus with 4 times with negative 1. All right, so we try to evaluate and we try to look at the answer. So as for this, we're getting negative 16 over 3, right? So minus with negative 1, so we have 11 over 3 for this case, 11 over 3, so which give you negative 27 over 3, which is negative 3, right? Negative 3. So because we know that we are actually evaluating the area, right? We are evaluating the area. So there is no negative value for area. So in order for solving this case, because this is the area problem, we can try to put modulus, as we know that we are actually evaluating the area. So while we put modulus, the value here, you are getting 3 units square, right? So means that the area under the curve for the region A is actually 3 units square. So how about area B, right? As we want to evaluate area B as well, because it's the area under between the curve and the straight line, means that between this curve and the x-axis and the straight line negative 1 up to 4, right? So B is above the x-axis. So for sure that when you integrate, you will getting a positive value. So I will tell you why in the next video, in another video, why is it getting negative, right? Why is this getting negative? Okay, I will tell you later. So in this video, my purpose is to teach you how to finding the area of this region. So for part B, so and I'm integrating from 2 to 4, right? area B, area of B. So I'm integrating from 2 to 4. So under the curve of x squared minus 4, right? X squared minus 4 with respect to x, right? With respect to x, it's between this curve and the x-axis. So then we integrate, we're getting x to the power 3 over 3, negative with 4x. Now it's from 2 up to 4, right? From 2 up to 4, sorry, as this value, it should be 9, right? I've forgotten that 3, and this one should be 9 units square, as 27 over 3 is 9, all right? Okay, so now for these cases here, so I'm going to substitute with 4 cubed over 3 minus with 4 times with 4. Take away 2 to the power 3 over 3 minus with 4 times 2. Right? So let's evaluate this. 4. So we're getting 16 over 3. Take away 2. So we're getting negative 16 over 3. Right? We're getting negative 16 over 3 for this side. So let's see what you get. You are getting 32 over 3. Right? 32 over 3 unit square. Right? Unit square. So it means that the total area under the curve. Okay? The total area. So the area under the total area of the shaded region will be the area of A, which is 9 unit square plus with 32 over 3 unit square. Alright, which we're giving you 9 plus 32 over 3, 59 over 3. Alright, 59 over 3. So it's 19 2/3 unit square, right? So this is the way we evaluating the area under a curve when there is only one curve, and between this curve and the x-axis, alright? So there's the region below the x-axis. While you're integrating, you are getting a negative value. That's why I put modulus, because I understand that I want to find the area, right? Area of this region. So I put a modulus to get a positive value. And for area of B, so I find as usual, because it's above the x-axis, definitely they will get a positive value. So I total up these two, I will get the total area. So let's move on with the next example. Right, okay, let's look at this second examples. So I'm going to sketch the graph for you first, so that you can see where is the region bounded. So x, 8 minus x cubed, so negative x cubed, so negative x cubed plus 3, right, plus 8. So you're already very familiar with this graph, where it's a cubic function with the area of, so it's look like this way, right? So where the x-intercept will be 2, right? The x-intercept will be 2 in this case. So if you calculate, so then they have then you can see that it's from negative 3, it's from negative 3, x equals to negative 3, from this region up to x to 3, right? X is 3. So it means that, let's say if you drawing this, and you can find out that this is 2 and during 3, so there is a region, there is an area bounded by the curve and the x-axis below the x-axis. So this region, right, from 2 to 3, and this is from negative 3 up to 2. So we have to consider these two separately, because this may give you a negative value here. So then you have B, then you have region A, right? So as you know that if you integrate from negative 3 up to 2, by using the graph, you can observe that if you integrate from negative 3 up to 2, you get a positive value because it's above the x-axis here. So, and this, you are getting a negative value. Alright, so area of A. So area of A, definitely you're getting a positive value. So area of A, you will integrate from negative 3 up to 2, right? It's from negative 3 up to 2. So the curve, which is 8 minus x to the power of 3 dx. Right? So this is the way you're finding area of A. So how about area of B? So area of B, the region B, so it's also integrate from 2 to 3. So from the smaller value to the bigger value. So from 2 to 3 is under the curve of 8 minus with x cubed, right? 8 minus with x cubed. So then dx, because of this is the area under the x-axis, okay? Under the x-axis, where it's only between the curve and the x-axis, so definitely they will give you a negative value here when you calculate the. So at first I put a modulus here because I know that I want to evaluate the area of this region, which should not be negative. So then I start integrating this. I have 8x minus with x power 4 over 4, right? So from negative 3 up to 2, and the same thing here also. So modulus, you integrating, you're getting 8x minus 8 power 4 over 4 from 2 up to 3. So as you know that the rule of the finite integral, where you substitute, you know 8 times 2 minus with 2 to the power 4 over 4, take away, negative 3, negative 3 to the power 4 over with 4. So giving you values and you're getting your answer for this case. So let's look at this. I'm going to calculate for you later. So in this case, you take 8 multiply 3 minus with 3 to the power 4 divided by 4. Take away 8 times 2 minus with 2 to the power 4 over 4. Right? So I'm going to find the area respectively. So for this, if you're using calculator, you are getting 12 and negative 3, you were getting negative 8x minus with x power 4 over 4. As you calculate negative 3, you are getting negative 177 over 4. For this, as you calculate 3, you are getting 15 over 4. 15 over 4, calculate 2, you are getting 12 here, right? So then try to evaluate this as 12 plus with 177 over 4. You are getting 225 divided by 4 unit square, and whereas for this you have 15 over 4 minus with 12, you have negative 33 over 4, right? Negative 33 over 4. That's why you need a modulus, right? As early I got modulus here. So the modulus is to tell us that we want to evaluate the area. So as a 33 over 4, right? So the total area, right? The total area for the shaded region will be, I'm taking the area of region A, which is 225 over 4, plus with this area 33 over 4. Alright, okay, let's calculate. Plus with 33 over 4, we have 64.5. Alright, 64.5 unit square. So so this will be your total area. So as I want to introduce you is, when there is a region above the x-axis, so the value of the integrate of this finite integral will definitely positive. When the region is below the x-axis, so you are getting a negative value. So in this case, I'm going to put a modulus so that I can getting a positive value. So with these two, I sum up, I'm getting the total area under the curve. So hope you understand in this video. This is a basic of finding the area under the curve. That is only involving one curve and the x-axis. Alright, see you in the next video for the next type of the way of evaluating the area under the curve.